All right, so there's a data table provided that I'll have to click on in just a moment, representing miles per gallon of a random sample of cars with a 3-cylinder 1.0 liter engine. And we need to compute a z-score for a particular individual that obtained 42.3 miles per gallon, and then interpret the results. Well, to calculate that, we're going to need to know the mean and the standard deviation for that sample. So I'm going to open this up in Excel. All right, we've got it opened up, and I've enlarged it a little bit, at least for my eyes, make it easier to read. And then I've added a column so that I can label what we're looking at here. B, our average or mean, X bar for this sample. Got that going from column B, row 1, column B, row 24. And then we want our standard deviation. So equals STEV dot S, because this is a sample. And again, we're going B1 colon B24. If I go up to the top of the column and drag that right, then we get a little more precision. So our z-score, remember, is X minus X bar over our standard deviation S. And in that case, question was asking for, let's see, what value of X? It's asking for the value of X, 42.3. So let's get that calculation going. 42.3 score minus the mean that we have here. Divided by the standard deviation that we had here. All right, they probably wanted it rounded to the hundredths place. If that's right, it would be 0.96. Let's find out. Okay, 2 decimal places. So that is the hundredths place, 0.96. Make sure I'm typing that correctly. So that indicates that the data value is 0.96 standard deviations, because it's positive, above the mean. And check answer. Now we want the quartiles. And unfortunately, Excel seems to be following some different approach to finding quartiles. It's not that they're correct and what we're seeing in the textbook is incorrect, or vice versa. There are just some different opinions about how quartiles should be found. And in some cases, we get some minor differences. So now I'm going to open up the data in Excel instead. Sorry, and to say open it up in StatCrunch instead. And again, this is all stuff that I've shown how to find by hand as well. So let's see here. Okay. Got it. Go to stat and summary stats. Column, variable 1, quartiles. They're going to ask for quartile 2, which is the same as the median. All right, so we've got quartile 1 at 36.85. Let's get that put in, 36.85, coming up in just a moment. 36.85. Quartile 2, as I said, is the median. And we have that 38.6. Quartile 3, they're giving that as 40.95. So if I subtract quartile 3 minus quartile 1, I'm going to get the interquartile range, which therefore is going to be, should be 4.1. Now, because you're going between quartile 1 and quartile 3, you are getting either exactly how spread out the middle 50% is, or as close to the middle 50% as you can get. And then you're finding how spread out that is. So 4.1. By the way, I was just doing that computation in my head. I did not look at what StatCrunch gave, but it's giving the same thing. Good. All right. So checking that answer. And then determine the lower and upper fences. I'm going to go back to Excel here for a moment, given that we've got 4.1 for the interquartile range. Let me see here. Let me try something. Yeah, you can't get it to do any additional calculations in StatCrunch apparently. So 4.1. Well, the IQR equals 4.1. To find your lower and upper fences, because you've got the middle 50% between quartile 1 and quartile 3, and then between the minimum and quartile 1, you've got the lower 25%. Between quartile 3 and the maximum, you've got the upper 25%. We're trying to play it safe before we call something a potential outlier. So even though we've got double the percentage of data between quartile 1 and quartile 3 that we do from the minimum to quartile 1 and the maximum back to quartile 3, again, we want to play it safe. So we multiply by 1.5. That's more spread out than the middle 50%. Okay, we had quartile 1 was 36.85. So if we subtract the quartile 1 minus 1.5 times the interquartile range. I've already done that multiplication. It's going to give us the lower bound or lower fence. Okay, so again, that was 36.85 for quartile 1 minus 1.5 times interquartile range. Our lower fence, we should have 30.7. See if they agree with that. $30.7. Okay, it's good. And then the upper fence, well, take that same amount that was subtracted from quartile 1. Instead, you add that same amount to quartile 3. So for fence, quartile 3 plus 1.5 times interquartile range, and quartile 3 was 40.95. So add 1.5 times interquartile range, and we're getting 47.1. See if they like that answer. 47.1. So determining whether we might have any potential outliers, if we have anything less than 30.7 or more than 47.1, those would be potential outliers. You could have more than one. Now here, it would be a good idea to have the data in order. Do that here in Excel or on StatCrunch. Go from smallest to largest here. And we're trying to make sure that either we don't have anything less than 30.7, which we don't, or bigger than 47.1, but we do on the high end. We've got a potential high outlier of 49. So put that in, and again, check out whether or not there is agreement from my lab. And there is.